So, dear student, next question is what is given to us vapor pressure? Vapor pressure of chloroform and dichloromethane, trichloromethane and dichloromethane. These are organic compound haloalkane at 298 Kelvin, and these the vapor pressure are 200 and 415 mmHg, 200 mmHg and 415 mm. Chloroform have lower vapor pressure and dichloromethane trichloromethane have low because its molecular mass is high, so its vapor pressure is low. As its molecular mass is low because it contains 2 chlorine, it contains 3 chlorine, so it is heavier and it is lighter, so it's have higher. So as the molecular mass increase, vapor pressure decrease because boiling point increase. So its vapor pressure is high because its boiling point is low. Its molecular mass is low. So calculate the vapor pressure of the solution prepared by mixing 25.5 gram of the trichloromethane in chloroform and 40 gram of dichloromethane dichloromethane. So first of all we have to calculate the vapor pressure in the solution, by mixing, and second, mole fraction of each component in the gas phase, So this is the data given in the question. According to question, this is given to us. So dear friends, we have to find the vapor pressure of the solution. So we will apply the vapor formula for the total vapor pressure. So for this we have to calculate the mole fraction of, because the pure vapor pressure of this component is given but mole fraction is not given, so we will convert the given mass into moles. Given mass 40 divided by 85 and 25.5 divided by 119 molar mass. This is the molar mass of this, and this 85 is the molar mass of dichloromethane, 119.5 is the molar mass of trichloromethane. So given mass, these are the given 40 and 25.5 is the given mass. So we convert the given mass to moles, and from the moles we will calculate the mole fraction. So by calculating the mole fraction, we will put the value in the formula, and by putting the formula we find the total pressure. Now next, mole fraction of each component in the gas phase. So what is the formula for the vapor pressure in the gas phase? Total vapor pressure into pure vapor pressure in the pure state multiplied by mole fraction. So mole fraction is given, vapor pressure of in the pure state is also given, so we find the this is the partial pressure. So the formula in the gas phase is partial pressure into mole fraction in gas phase multiplied by total pressure. So partial pressure divided by the total pressure gives the mole fraction in gas phase. So partial pressure divided by total pressure, this gives the mole fraction in the gas phase. So we will find from here the partial pressure of each component equal to vapor pressure in pure state multiplied by mole fraction. So we for both the component dichloromethane and trichloromethane, we will find the partial pressure, and by putting, and we have already calculated the total pressure. We have find the total pressure from the formula 347.9 mmHg. This is the total pressure, and this is the partial pressure. So we will divide the partial pressure by total pressure, and we get the mole fraction in gas phase. Similarly, for trichloromethane, we will find the vapor pressure in gas phase is mole fraction in gas phase. Is equal to partial pressure divided by total pressure. This is the mole fraction in gas phase. So dear friends, I hope it is clear to you how we will find the mole fraction of each component in the vapor phase and the vapor pressure of the solution. Calculate the vapor pressure of the solution by mixing. So we use the formula. So we have used the formula of total pressure, and from the total pressure we will find the mole fraction in gas phase. We will find the total pressure. So for this we first calculate the mole number of mole, and from the number of mole we find the mole fraction, and from the mole fraction we find the total pressure, and from the total pressure we find the mole fraction in gas phase, mole fraction of each component in gas phase. So mole fraction in liquid phase is represented by X, and in gas phase it is represented by Y. So mole fraction in liquid phase, from the mole fraction of liquid phase we find the total pressure and partial pressure. So total pressure and partial pressure gives mole fraction in gas phase. So I hope it is clear to you. Thank you.